So our program today, we have a special guest, Mollie Mahoney. She's a native of Detroit, and she has earned a Bachelor's of Science degree in Natural Resources and the Environment from the University of Michigan, and she's also earned bachelor's and master's degrees in civil engineering from Wayne State University. She's been a project manager with the U.S. Army Corps of Engineers in the Detroit District for 15 years, and she's worked on a variety of navigation, flood control, and Soo Locks projects. And Mollie's currently the senior project manager for the new lock at the Soo. So with that, Mollie, go ahead and take it away.
Great, thanks, Michelle. Good afternoon. It is an exciting time on the new lock at the Soo project. I really appreciate you guys inviting me to come in and speak today. As you all know, the Soo Locks are vital to the Great Lakes shipping industry, our regional and national economy, and our national security, which is why we are increasing resiliency at the facility by constructing a second 1,200-foot lock chamber at the Soo Locks. So today I'm going to provide some just a little background and history on the project and the Soo Locks, talk about why we're constructing a new lock, and then go into a deep dive update on what has been accomplished over this last year. Okay, so you are on the important slide. Great. So most of you are probably familiar with this, but just background and context are key. So I just want to briefly cover why the new lock and the importance of the existing facility, why that facility is so important. So the Soo Locks are a critical link in our nation's supply chain of iron ore from those mines up along the shores of Lake Superior to those steel mills along the lower shores of the Great Lakes. We've got two operational locks at the facility. We have the you can see that in the bottom right-hand picture. We have the Poe lock, which is 1,200 feet long, and the MacArthur lock, which is 800 feet long. So 95% of all of the iron ore mined in our nation passes through the Soo Locks facility, and due to vessel size, nearly all of that iron ore tonnage is restricted to the Poe lock. So we've got the iron ore up here and the steel mills down here, and the Poe lock in the middle connecting the two. So the Poe lock was constructed over 50 years ago with a 50-year design life. It is the Achilles heel of that supply chain of iron ore for our nation. And it is estimated that within 2 to 6 weeks of an unscheduled outage of the Poe lock, 75% of our nation's high-strength steel production would cease. That would shut down our automobile, appliance, and heavy equipment manufacturing across our nation. It's estimated that a 6-month outage of the Poe lock, an unscheduled outage, would result in 11 million jobs lost and a $1.1 trillion economic impact. Next slide. So on the left of this slide is the current facility, and on the right is a rendering of our future facility. The new lock will be constructed within the footprint of the Sabin lock. However, the new lock is 30 feet wider and 9 feet deeper than that Sabin lock chamber. The Davis lock will be filled in with construction debris, as you can see in that picture on the right, and a new pump will be constructed within the footprint of the Davis chamber at the far downstream end. So the new lock and the Poe lock are not only the same size, they also have many of the same components and systems to help reduce the number of spare parts that we need on site. So the miter gates are interchangeable, the filling and emptying systems are identical, which means our culvert valves and our bulkheads are all interchangeable between the two locks. The ship arresters will be the same, so we only need one extra motor on site, one extra ship arrestor boom. The list goes on. However, while we were going through the design process, there was an intentional effort to have the new lock incorporate new safety features and new technology that'll help with operations and maintenance and transiting the new lock facility. So during the design process, we were able to improve safety by including the hands-free mooring system on our new lock. Hands-free mooring is, I'll touch on it in a little bit later, but it's a large vacuum pad system that will reach out and hold the vessel and ride up and down on rails instead of using traditional line handling. We also have incorporated larger galleries in our lock chamber monoliths. So galleries are like long hallways in the lock walls that are used to access mechanical and electrical equipment. And on the new lock, they'll be a couple of feet wider and a couple of feet taller than on the PO lock, just to help ease those long-term operations and maintenance activities on the new lock. Next slide. So the remaining work for the new lock was broken down into 3 phases back in 2018 when we did our big reevaluation study. So those 3 phases are listed here in the order in which the work was initiated. So not going to spend too much time on the slide because I'm going to go into each phase, but just wanted to point out that the phase 1 contract for deepening the upstream channel was completed in August of 2022. Our phase 2 contract for rehabilitation of the upstream approach walls is nearly 80% complete, and then our phase 3 contract is nearly 10% complete. Next slide. I'm not seeing the next slide, but it should be a slide on our allocations and capabilities. Michelle, can you confirm if it's
there?
Okay, there we go.
There seems to be a slight delay in when you see them and when I click the button.
Okay, got it. Okay, thank you. So the project has been funded $1.887 billion to date. That funding to date is represented with those gray bars on this graph here. And those funds have allowed for completion of the phase 1 deepening, substantial progress on phase 2 upstream approach walls, and then the award of 70% of the phase 3 construction contract. So the remaining minimum capability for the project is right around $560 million, represented by the yellow bars on this graph. The lion's share of that remaining capability is in 2024 and 2025, and it's tied to that phase 3 construction contract. So the way the phase 3 contract currently stands, it includes about 70% of the required work. And we have locked in pricing for the remaining 30% of the work, but that pricing has an expiration date because it just wouldn't be fair to require the contractor to hold that pricing indefinitely. So each remaining option on the contract, not optional, the work needs to be completed, but that's how the Corps of Engineers refers to our contracting mechanism. Their contracts, it's the Corps' option to award those options on the contract. So that remaining work on the construction contract is about 30% of the total work. If all goes as planned and we continue to receive efficient funding, we should be able to stay on track with a project completion in 2030, and with that meeting that about $560 additional million in capability. Next slide. Okay, so the first phase of construction was the deepening of the upstream approach channel to a depth of 30 feet. So this mile-long approach channel was not deep enough for modern vessels, and in some areas as much as 6 feet of bedrock needed to be removed. So the figure on this slide shows the scope of work for that contract. That blue line on this image denotes the limits of the channel deepening. So, and everywhere within that blue line, the channel is now a depth of 30 feet. The contract included removal of bedrock and overburden material. The material that was removed from the channel was placed on the northwest pier, which is shown in red here. It's property owned by the Corps of Engineers, and by the time construction is complete, that material will be as high as 80 feet above the surface of that pier and will act as a windbreak for vessels passing through the new facility. So this work was performed by Trade West Construction of Nevada. It's a $52.6 million contract awarded in January 2020 and completed in August of 2022. Okay, next slide. So on this slide, we've got some pictures of the upstream channel deepening construction. Sorry, there's a delay here. There we go. On the left is the eccentric ripper that was used to break up that bedrock on the bottom of the channel. And then on the right is an excavator removing that material from the bottom of the channel. Next slide. Okay, so here is some of the 300,000 cubic yards of material that was removed from the channel. Roughly 2/3 of the material was bedrock. And you can see the bedrock in the slides in the pictures on the left and in the center. The slide still hasn't forwarded for me. There we go. Bedrock in the left, and in the center picture, you can see that bedrock. And then on the right is overburden material. About a third of the material is that like sandy, silty, overburden material. Next slide. Okay, so phase 2 is the Upstream approach wall project. This project consists of rehabilitating nearly 4,500 lineal feet of the 100-year-old approach walls upstream of the new lock. So as downbound vessels enter the new lock chamber, they'll ride along that north wall. So rehabilitation of that north wall on the upstream side is a priority. And included in that rehab was new LED high mast lights and also new mooring bollards. So this was a $117 million contract awarded to Kokosi and Albrizzi in September of 2020. You can see here on this image that there are several different approaches to rehabilitation being employed here. That blue area consists of 34-foot diameter steel sheet pile cells constructed in front of the existing approach walls. The orange area are our transition walls, our steel sheet pile transition walls that connect that bumped out area back to the face of the existing wall. The purple areas are refaced with steel sheet pile and then backfilled with a flowable concrete. The green areas are being refaced with a soldier pile wall, consisting of H piles and then concrete panels that go between those H piles. And I'll show some pictures on all of those in just a second. Did want to point out the batch plant that's been constructed on site. So this project is very concrete heavy in terms of the scope of work that is being performed. And so transporting concrete trucks across the active navigation channel on barges, passing through freighters trying to transit the facility would be extremely inefficient and time consuming. So a concrete batch plant was constructed on site to provide all the concrete that's being placed for this project. Next slide. Okay, so here we've got some pictures from construction from that blue area on that image where we're constructing those 34-foot diameter steel sheet pile cells in front of the existing approach wall. So the circular cells basically act as a basket that then is filled with sand, aggregate, or concrete, and then we put a cap on top. So you can see here in the left picture is a template for those circular cells. And if you've been on site lately, you'll have seen that template still on site and one of our nose piers being stored there for the time being. In the middle is a sheet pile being driven down into the channel bottom using that template as a guide. And then on the right is that steel sheet pile cell that has been constructed. It's been filled with sand and aggregate and being topped off with about 5 feet of flowable concrete on the top of the cell. Next picture. So here's some pictures from 2022 progress on site. The most visually, visual progress made on site to date has been the construction of this portion of the approach wall. So it's a time lapse from April of 2022 to September of 2022, and you can just see those circular cells on the left being filled with aggregate and sand, and then as you move to the right, you can start to see concrete being filled in the top of that cell, those 5 foot of flowable concrete, and then on top of those cells will be the walking surface of the approach wall. So there's a concrete cap placed on top of all of the cells where the mooring bollards are placed and the high mast LED lights are placed, and that'll be the walking surface of the future approach walls. Next slide. Okay, so here are some pictures from that orange area where steel sheet pile transition walls are being constructed to connect the face of that bumped out area with those 34-foot diameter cells back to the face of the remainder of the approach wall. So on the left is our northwest transition wall. You can see the face of that wall made out of steel sheet pile, and then behind that steel sheet pile there placing a flowable concrete. On the right is a final cap being placed on top of the transition wall on the south side of the channel. including the formwork that's being used to form up that concrete cap. Next slide. Okay, so here are some pictures from the purple area of work. So in these purple areas, the existing wall is being faced with a new steel sheet pile wall. On the left, you can see the steel sheet pile has been placed and is being in the process of being anchored into place. Once it's anchored into place, then it'll be backfilled with a trimmy concrete. So you can see that picture on the bottom right is one of the methods that's being used to anchor that wall in place. So that is actually a 4-foot long pin that is placed at the bottom of that steel sheet pile wall, down at the bottom of the channel, and helps hold the bottom of the steel sheet pile wall in place before the trimmy concrete or the flowable concrete is placed behind it. That's a view from a diver's video camera. We use divers for inspection, for placement of the pins and for inspection of the pins before the concrete is placed. And then you can see on the top right, formwork for concrete caps that were placed on top of that steel sheet pile wall. Next slide. Okay, so here we've got some pictures from the green area. This area is the area where we're placing a soldier pile wall in front of the existing wall. So this wall is constructed with H piles that are placed about 8 feet apart with concrete panels that slip between those H piles. And in addition, that wall system includes drilled shaft deadmen that are placed back behind the wall to help hold it in place. You can see pictures of that here. In the top left, we have a drill rig installing those drilled shafts. And then the bottom left, you can see a row of those drilled shafts, deadmen, that are back behind the new wall. Roughly 50 of the 70 drilled shafts that need to be placed have been constructed, and that work should be wrapped up in the next few weeks. Once that drilled, well, I guess now that we're getting near the end of finishing those drill shafts, we are going to start placing those H piles in the concrete panels. And if you are up at the Soo, you will likely see that first H pile being placed tomorrow. We are getting started on that late this week, and those H piles will go in, and then as I mentioned, they'll place those concrete panels between the H piles, and those concrete panels will face the entire face of the existing wall. Then they will backfill behind that soldier pile wall with flowable fill and put a cap, that concrete cap, on top of the entire length. Next slide. Okay, so phase 3 is construction of the new lock chamber, which will be 1,200 feet long and 110 feet wide, 32 feet deep, matching the dimensions of the PO lock, not an inch wider or an inch deeper. The phase 3 contract also includes construction of the downstream approach walls, a bridge to our hydropower plant, and a new pump wall that will service the entire facility. The contract was awarded in July of 2022 to a joint venture between Kokosing, Albrizzi, and Trailer Brothers. And the current contract value is $1.347 billion. So that's 72% of the total contract value of $1.872 billion. As I mentioned, as we've received funds, we have added additional work to the contract, and then we have about 30% of that work that's remaining to be added to the contract. In 2023, the contractor has worked on activities that are required to dewater the construction site, which will happen next year. So they have focused on demolition of existing structures, moving utilities, constructing a new bridge to the new power plant, and we'll be starting construction of the coffer cells in the next month or so that will be required to dewater the construction site. Next slide. So here we've got some key features of the new lock. The lock walls are comprised of a series of concrete monoliths. They're shown in purple and orange here, and they are basically like giant Lego blocks that fit together. They're placed in 5-foot lifts, 5-foot placements, and they are each one is roughly 70 feet tall. So the chamber monoliths are shown in orange. Those monoliths are thicker at the bottom, and then they narrow to about 25 feet at the top. They are fairly simple compared to the wide wall monoliths. The wide wall monoliths are shown in purple, and that is where all of the mechanical and electrical equipment is housed in those monoliths, and the miter gate leaves are also anchored to those monoliths, so they're more massive in size. The purple monoliths are about 60 feet wide, and that width carries the entire depth of the wide wall monolith. The miter gates are shown in red, and we will have one upstream miter gate and one downstream miter gate on the new lock. The gate leaves are 61 feet wide, and each leaf weighs more than 200 tons. And as I mentioned earlier, the gates on the new lock will be the exact same dimensions as the ones on the PO lock, so they are interchangeable, another one of the interchangeable features to reduce spare parts required on site. The ship arresters are shown in yellow here. We will have ship arresters on either side of each gate leaf, so one on the upstream side and one on the downstream side, and that'll help protect our gates from vessel impacts. The filling and emptying system is shown in blue on this picture. As mentioned, it's the same filling and emptying system as on the PO lock. The large culverts in the north and the south monoliths feed smaller lateral culverts in the floor of the lock chamber that are used to fill and empty the chamber. You can see the hands-free mooring system units shown in green on this figure. There are 4 units on the north wall and 3 units on the south wall. As I mentioned, the hands-free mooring units are comprised of large vacuum pads that you can see those in the picture there that ride up and down the face of the lock wall on a rail system. This system has been implemented in all 15 locks on the St. Lawrence Seaway over the last decade or so, and they have had great success using the system. So we are incorporating the system on the new lock, and it really will help reduce the dangerous task of line handling on the new lock. Next slide. So what makes this project really unique as compared to other projects is the remoteness of our site. So not very flashy pictures here, but just wanted to give a taste of the challenges of working on our construction site. So it's in the middle of the St. Mary's River on an island, separated from land by an active commercial navigation channel. You can see here on the left a lubrication truck being barged over from the Sault Ste. Marie mainland to service the many pieces of construction equipment on the site that require lubrication. Just evidence that every little task requires a large amount of effort to complete. On the right top is a temporary bridge being constructed to provide access to, you can see in that kind of plan view of the construction site, that green triangular piece of land on the north side of the construction site where we're placing fill material and rerouting some electrical lines. That in order to access that area on the facility, thanks for bringing that up, Michelle, we had to construct a bridge just to get across to that side of the facility. That bridge will be removed after construction is complete. And then on the bottom left, you can see a picture of the contract workers being shuttled to the construction site. At the peak of construction, we're anticipating 400 to 500 workers on site each day. Each of those workers needs to be shuttled from the mainland over to the construction site. Next slide. So I've got a few slides here covering the demolition of existing structures. Here are some pictures of the demolition of the downstream nose pier. So if you live in Sault Ste. Marie, you've probably heard the tap, tap, tapping most of the summer long of equipment breaking up concrete. Majority of that work has been on the downstream and upstream nose piers on the lock facility. So here you can see just what the nose pier looked like prior to the demolition starting in May of 2023, and then how it's progressed throughout the season. And that picture on the right just taken earlier this week. This demolition work is obviously underwater, which complicates things and makes just slows down the progress. It's a lot harder to demolish concrete structures underwater versus above water. In addition, these concrete structures are over 100 years old, and concrete continues to harden when it's in this sort of marine environment, making breaking up that concrete even more challenging. Once this concrete nose pier is completely removed, then that will be the location for the new cofferdam cells right along that area. So this activity is a precursor to constructing the downstream coffer cells. Okay, next slide. Okay, so here you can see some preparation for removal of the Davis lock miter gates. The contractor has started removing those miter gates, and before those miter gates can be removed, there's selective abatement of lead paint, and then just other features that need to be removed before those gates can be lifted by a crane, put on a barge, and taken off site. Next slide. So here's some pictures of some of those miter gates from the Davis lock chamber being removed. One of the large cranes on site is used to lift that miter gate and then placed on a barge, and those miter gates are taken off site for recycling for the metal that they have. Next slide. Here are some pictures of the demolition of the upstream nose pier and the steam plant. The steam plant had quite a bit of lead and asbestos in it, so that is why it is covered in that white, kind of encased in a white material to help contain those substances while the building is being demolished and the material is being removed. Next slide. Okay, so another feature that is being focused on this year is seepage prevention. So when the lock is dewatered, it is very important that we not only pump out the water to begin with, but also prevent additional water from entering the dewatered construction site. So you can see here a couple of different features that have been installed this year and continue to be installed to help prevent that groundwater seeping into the dewatered construction site. So on the top left picture is a picture of the SCCB wall. That's a soil cement bentonite wall, and it is being placed, you can see there in green, it's kind of a long line along the north side of the north Sabin lock wall. And then there is a grout curtain that's also being placed. You can see that picture in the top right. And it's kind of hard to tell, but that kind of visual there is just showing how the grout curtain is placed. Holes are drilled at a angle to the face of the grout curtain, and then grout is pumped into those holes. And at the end of the day, it's basically an underground curtain made out of grout that prevents that groundwater from seeping into the new lock. You can also see here on this slide that purple outline that's labeled as the projected damming surface. So that purple outline denotes the area that will be dewatered during construction. So by late next summer, that entire kind of everything that needs to be constructed to have that damming surface ready to go should be complete, and then that whole area will be dewatered. The water will be pumped out of that whole area. Next slide. Okay, so here we've got some monolith stability features of work. So right now there is water in the Davis and the Sabin lock, and before we remove that water from those lock chambers, we need to put in some features that will keep those lock walls in place once the water is out of the chamber. So the water right now is helping to keep those walls in place. And so what's going on right now, you've probably seen strut hangers being placed over the last week or so. You can see in that top left picture, these are large steel structures that have been placed on the sides of the Davis chamber and the downstream side of the Sabin chamber, and they will hold 60-inch diameter struts. They'll be placed across the chamber to keep those walls in place when we dewater the lock. You can see that from one of our renderings in the bottom, those struts across the chambers. And then on the right-hand side, you can see another feature that's being installed right now to help provide that stability of the monoliths before dewatering are the rock anchors. And so right now they're getting ready to place those 40 to 60 foot long anchors that'll be drilled down through those monoliths and will help hold them in place during dewatering. Next slide. So here you can see a utility shaft that's being constructed on site. Needs to be constructed before we can demolish the Sabin lock. And in order to build this utility shaft, bedrock is being blasted. So we're blasting the bedrock to fracture it and make it easier to remove. Blasting began back in August and will continue to occur on about a weekly basis through the end of this construction season with relation to this utility shaft. Next slide. So here we've got some work that's also going on this year, getting ready to excavate next year and remove the Sabin lock, and then also excavate bedrock down to what we call our founding elevation. So basically the elevation of the bottom of the new lock monoliths. So it's really important to make sure that when we start placing those new monoliths, those 70-foot tall monoliths, that they are placed on structurally sound bedrock. And so we've got Jacobsville sandstone up at the Soo that has weak clay seams that pass through the Jacobsville sandstone. So what's going on this year is a lot of drilling of rock cores. So you can see in that bottom left picture, a drill rig on a barge in the Sabin lock chamber, taking cores through the bottom of the Sabin lock all the way down through the bedrock. Those rock cores are brought out, and you can see in that top right picture, our geologists look at those rock cores and just verify that where we had planned on starting construction of the monoliths is the best place to found that bottom of the monolith. On the bottom right, you can see, if you're up at the Soo, you've probably seen this little building pop up on the northeast pier. It is a building where all of the rock cores are actually stored for this year. Next year, we'll have another building that's on the other side of site, but just a challenge of working on this confined construction site, having to deal with some challenging logistics. Next slide. Okay, so according to our latest economic modeling, the project is expected to generate 1,200 jobs, a little over 1,200 jobs on an annual basis. At the peak of construction, about 600 direct jobs with about 500 workers on site each day. The project will require 1 million tons of limestone or granite, 110,000 tons of American-made cement, and 25,000 tons of American-made steel. Next slide. All right, it's been my pleasure to present, and I'm happy to take any questions.
Okay, thank you, Molly. What we would like for everyone to do is use the chat button that's on your screen if you have questions, to go ahead and type those in. Meanwhile, while I give you a chance to enter those questions, I'm going to quickly review the status of our visitor centers. Right now, the Duluth Visitor Center is open 6 days a week. They are closed on Wednesdays, but open from 10 a.m. until 4:30 p.m. Their cell phone tour is still available outdoors, and there is a virtual online tour of the visitor center. I'm going to quickly drop a link in the chat that I had promised earlier. This is all the links. So cut and paste the ones that you want to retain. In the Soo here, we are open daily from 10 a.m. until 7 p.m. through October 1st or 31st. We'll be closing for the season October 31st, but the park will be open from 9 a.m. until 9 p.m. through the beginning of November. And we do have most of our exhibits available online on our Detroit District homepage. And let's start turning some questions over to Molly. Jeff is asking, on completion, are there any plans to close and refurbish the Poe lock? And that actually, I'm going to glom on my question to that too. I was wondering, because the Poe does not have downstream ship arresters. Will they be doing anything to replace those or bring that up to date?
Sure, great questions. So the plan is, once the new lock is online, the Poe lock will be taken out of service for probably 2 to 3 years to perform a pretty major overhaul and rehab of the pole lock. There's certain features on the pole lock that are badly in need of help but can't be addressed during our 10-week winter shutdown period. We need an extended period of time. So all of those projects will be addressed. It'll probably take a couple of years to get that done. And during that period of time, the MacArthur lock and the new lock will be used. In terms of the downstream ship arresters, so the reason why there are downstream ship arresters on the new lock is because on the new lock we have the hands-free mooring system. And so the hands-free mooring system, typically now, without hands-free mooring, the vessels, line up on the approach wall, line handlers get off, and line handlers walk with that vessel down that approach wall into the chamber. And with the hands-free mooring system, line handlers will not be put out onto that approach wall. So there's just a slightly higher risk of vessel impacts on the miter gates. And so it's not, something that we are overly concerned about, but it does warrant the addition of downstream ship arresters on the new lock. I believe the pole lock was actually constructed with the downstream ship arresters, but they were taken out of service. So, so that's why they're on the new lock.
Okay. And will the PO be fitted with these hand-free mooring systems as well?
That's a great question. So that is something that's being considered. It may be in the future, but no decisions have been made yet.
Okay. And then Marty is asking, what is the excavation work along the south wall of the NPP head race? So that's that new power plant for those who are not familiar with our acronyms.
Oh, sure. That is it's a new utility shaft that's being constructed. So that was the pictures of that circular kind of shaft that the blasting is related to.
Okay. And I have probably a silly question. I'm just curious, what are those struts going to be made of? You said they're going to be 5 feet in diameter to help stabilize those walls.
Yep, they are steel struts. Yep.
Okay. Those are going to be a little heavy.
Yes, they are. They are going to be massive, but it just wasn't. We tried to find ways to avoid doing that, but there was no way. On the Sabin lock, most of the Sabin lock will not have those struts because we unload the pressure on the wall. We excavate the soil from behind the Sabin lock walls before we dewater. But on the Davis lock, on one side you have the PO lock, and then on the other side you have the new lock. You can't excavate all that soil on the Davis lock, so that's why we had to use those struts.
Okay, cool. And I have a question that we hear all the time in the visitor center, which is it still on schedule? Will it be done in 2030?
Yeah, so if we continue to receive efficient funding, the project will be done in 2030, unless some crazy unforeseen condition comes up. The project, the construction work that has been awarded to date, the contractor is on schedule with that work.
Excellent.
Yep.
And you were very thorough. We don't seem to have any more questions coming in. So I am going to, once again, very briefly, highlight next month's program on November 2nd, that Edmund Fitzgerald program with Rick Mixter, who has spent 20 years researching the wreck, and most notably, I would argue, is one of the very few people that actually have been in a submersible and visited the wreck site in person. That's going to be a great program, and we hope you will join us again for that. And again, this program has been recorded. We'll be uploading it to our YouTube and Facebook pages probably sometime tomorrow. So it will be available for you to share with people or to watch again. And I want to thank Mollie for joining us. And I want to thank all of you who have taken some time out of your day to join us here in the Virtual Visitor Center.
Great. Thanks, Michelle.
Bye, Mollie.